Lubrication. In manufacturing processes, as known in various sections, the surface of the tools, the dies, and the workpieces are subjected to forces and contact pressures, with a range from a very low values to a multiple of the yield stresses of the workpiece materials. Also, a relative speed from a very low to a very high, and finally a temperature which range from ambient to a melting temperature. In addition, to selecting appropriate materials and controlling the process's parameters to reduce the friction and the wears, lubricants or more generally the metal working fluids are applied widely. Lubrications is the control of the friction and wear by the introduction of a friction-reducing film between the moving surfaces in contact. Lubricants used can be a fluid, solid, or plastic substances. There are four regimes of lubricants that are generally of interest in manufacturing operation: thick film lubrications, thin film lubrications, mixed lubrications, and the battery lubrication. In a thick film lubrication, the surfaces are separated completely by a film of lubricants, and lubricant's viscosity is an important factor. Such film can develop in some of the regions of the workpiece in high-speed operation and also can develop a high viscosity lubricants that become trapped in a die workpiece interfaces. A thick lubricant film results in a dull, grainy surface appearance on the workpiece after the forming operations, with the degree of the roughness varying with the grain size. In operations such as the coining and the precision forging, trapped lubricants are undesirable because they prevent the accurate shape generation. As load between the die and the workpiece increases, or as the speed and the viscosity of the metal working fluid decreases, the lubricant film becomes thinner and the process is known as a thin film lubrication. This condition raises the friction at the sliding interfaces and result in a slight wear. In mixed lubrication, a significant portion of the load is going to be carried by the physical contact between the asperities of the two contacted surfaces. The rest of the load is going to be carried by the fluid film trapped in the pockets, such as the valleys between the asperities. In balloon lubrication, the load is supported by contacting surfaces that are covered with a boundary film of lubricant, forming a thin molecular lubricant layer. The film is attracted to the metal surfaces and prevents the direct metal-to-metal contact of the two bodies, thus reducing the wear. The functions of the metal working fluids are to reduce the friction, thus reducing the forces and the energy requirements and any rise in the temperature. Also, it's going to reduce the wear, thus reducing the seizure and the galling. Improve the material flow in tools, dies, and the molds. Acts as a thermal barrier between the workpiece and its tool and the die surfaces. Thus, will prevent the workpiece cooling in hot working processes. Act as a release or the parting agents for the substances that help to the removal of the ejection of the parts from the dies and the molds. Various types of the metal working fluids are now available with diverse chemistries, properties, and characteristics that fulfill these requirements. The oils maintain a high film strength on the surfaces of the metals as it readily can be observed with trying to clean an oily surface. An emulsion is a mixture of two immiscible liquids, usually an oil and water, in various proportions, along with some additives. The synthetic solutions are chemical fluids that contain inorganics and other chemicals dissolved in water. They do not contain any mineral oils. The soaps, the greases, and waxes are semi-solid lubricants. The metal fluids usually are going to be blended with the various additives, including the oxidation inhibitors, the rust-preventing agents, the foam inhibitors, the wetting agents, the odor-controlling agents, and the antiseptics. Because of their unique properties and characteristics, several solid materials are used as lubricants in the manufacturing operations. Described here are the most commonly used solid lubricants. There's a unique lubricant selection strategy. which based mainly on the lubricant specification and its interaction with the surfaces. Also, the database of the lubricants and the lubrication points, the lubricant supply approval processes, the lubricants approval procedure, and the product environmental health and safety. Biological and environmental considerations are important factors in the selection of the metalworking fluids. The hazard may result if one contacts or inhales some of these fluids, such as the inflammation of the skin. The improper disposal of the metalworking fluids may cause the adverse effects on the environmental as well. To prevent or restrict the growth of the microorganisms, such as the bacteria, the yeast, the molds, the algae, and the viruses, the chemicals are added to the metalworking fluids. Much progress has been made in developing environmentally safe fluids and the technology and the equipment for their proper treatments, recycling, and disposal.